Hello everyone, my name is Anuradha. In this video, I will briefly introduce how to design and play the Mastermind game with MATLAB's App Designer. The game's objective is for a player to guess the secret color code chosen by the computer within 10 guesses. The computer is the code maker and the player is the code breaker. The code is a sequence of 4 colored pegs chosen from 6 available colors. The code breaker must make a series of pattern guesses for the 4 colors. After each guess by the player, the code maker gives clues as feedback about the accuracy of the guesses. This comprises 2 clues, a black peg for the number of color pegs of the right color and in the right position, and a white peg for the number of pegs of the right color but not in the proper place. The UI for the game is built with App Designer. This is a built-in environment for developing professional apps for anyone to use and provides an extensive set of UI components. The code view in App Designer allows the user to navigate through the code and quickly locate, rename and set the properties of the UI components easily. It also allows the user to manage the callbacks for the selected component. These functions are possible through the component browser pane of the code view. The code browser pane consists of callbacks, functions and properties tabs. These are used to add, remove or modify the callbacks and create private or public custom properties and user-defined functions. In the code view, the uneditable sections of the code are grayed out since they are generated and managed by App Designer, whereas the white editable parts consist of the functions defined by the user and the custom property definitions. The app layout pane of the code view consists of the thumbnail of the UI components, and selecting a component in the thumbnail selects the component in the component browser. In this app, callbacks are created for every color button click, and the other buttons used in the game are Result, Reset and Reload, and Change Current Row. There are 2 private properties, I and J, defined for iterating through the rows and columns during the game. 2 public properties are created. One is a struct variable play, whose fields are initialized at the startup and accessed and updated during the game. The fields include the total number of colors, number of rows and columns of the board, current color number, current row number, and current row colors. The code uses an image for the board, which is in the mat file format and needs to be loaded on the startup function call of the app. It consists of the board matrix, the color pegs, and the black and white pegs to be loaded as the game is being played. The second public property, where, holds the contents of this mat file. The IAmShow command displays the current state of the board. The properties of the board with the colored pegs and clue pegs are set as per these commands. Each color is assigned a color number: red 1, blue 2, green 3, yellow 4, pink 5, and orange 6. Before moving ahead, I want to show you something. For the last 28 days, roughly 5.9% of the viewers have subscribed to our channel based on our YouTube statistics. If you have not subscribed to our channel yet, we request you to subscribe now. Let us jump back to our video. The empty board is loaded along with the color buttons on running the code. A random selection of 4 colors is generated as the secret color code solution and is sampled without replacement. This implies that each color chosen can appear at most once in the set of 4 colors, and there are no duplicates in the solution. The code for implementing the startup state of the game is shown here in the startup function of the app. There are 6 buttons for the players to select 4 colors from 6 available colors. For every button click, the board gets updated with the color chosen by the player. The board updates are done as per this section of the code. The user interface includes a Change Current Row button, which allows the user to change the colors on the current row before confirming his current guess. This is the section of the code defined for changing the current row. Once he is done with the guess, he must confirm his guess by clicking on the result button. The player can see the results of his guess only after filling the entire row and clicking on the result button, and will be prompted to fill the whole row if he hasn't already. Once the result of the current row is displayed, he can select the colors for his next guess. The result button is implemented in this part of the code, which implements the if conditionals depending on the state of the game. If the player wants to start the game again, he needs to click on the reset button. Once the reset button is clicked, the image of the board and buttons are cleared, all the game variables are reset, and he needs to click on reload board to start a new game. Once the player guesses all the colors correctly with the correct positions, 4 black pigs are shown with a message as winner. After 10 chances, if the player has not got 4 black pigs, that is all 4 correct colors with the correct positions, a loser message is shown. Once the game is over with the result of either win or lose, the player can click on reset and reload to start a new game. The code for the reset and reload is shown here. Now let us look at how this game is to be played. The first thing that the player needs to do is run the application. Suppose that the solution generated by the codemaker is green, orange, pink and red. Now the player must start making guesses about the pattern of 4 colors by clicking on the color buttons to fill the columns in the current row from column 1 to column 4. After he makes a guess, he must click on the result button. Suppose a player does not fill the entire row with 4 colors before clicking on result, he will be alerted to do so. Suppose that the first guess made by the player is red, blue, green and yellow. If he wants to change his current guess, he must click on change current row and repeat the process of filling the columns 1 to 4 of the same row. After he clicks on result, the computer validates his guess by giving him the clues as 2 white pigs. This indicates that both the colors, red and green in this case, are guessed correctly but are in the wrong places. The only information that the player receives from the computer is how many colors he has got correct in the right places and wrong places. He must figure out for which colors these pegs are given. Then the game continues and he makes a second guess as blue, orange, green and red by clicking on the color buttons and the result button. For this guess, he receives 2 black pigs and 1 white pig. The game continues until he guesses all 4 correct colors in the right places, green, orange, pink and red, for which he is given 4 black pigs and a winner message. If you want to access the MATLAB codes developed by me, visit the blog with the link in the description and purchase the blog resources. We have covered many more topics using the MATLAB App Designer, some of which are IPL with MATLAB, where we perform programming with the Indian Premier League and MATLAB and visualize the progress of each team as it's happening with the graphical power of MATLAB and App Designer. Blood cell counter with MATLAB, where you will learn the concepts of image segmentation, finalizing and counting red and white blood cells in MATLAB App Designer. This webinar is a must-watch if you want to create a project based on RBC and WBC segmentation. And fitness tracker with MATLAB. Here you will learn about your fitness and health and the importance of BMI, WHR, WHTR, etc. You will be able to track your fitness within MATLAB with your application. Thank you for watching this video. Do like this video if you found this helpful. If you have any queries, please post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future. MATLAB is our feature. Happy MATLABing!